Hello guys and welcome to Eedemy, the Electrical Engineering Academy channel. Picking the right cable size is like choosing the perfect shoes, too small or too big, and things just won't work. Let's break down the basics of cable sizing with a mix of science and practical examples to keep it simple. Choosing the correct cable size is not just an exercise in math, it's about ensuring safety and efficiency in your electrical system. Your cable size must handle at least 125% of the full load current. But that's just the tip of the iceberg. Factors like ambient temperature, voltage drop, installation methods, and short circuit capacity play a big role. Your cable choice must adapt to real-world conditions. Let's explore how. Factors influencing cable selection. 1. Ambient temperature factor. Heat reduces a cable's ability to carry current. If you're working in a desert-like environment, you may need to upsize your cables. Scientific impact. When ambient temperature rises, a cable's current carrying capacity decreases due to the increase in its internal temperature. According to standards like the NEC or IEC 60364-2, you should consult current correction tables based on temperature. Practical example. Imagine a 6 mm squared cable operating in an area with a 45 degrees Celsius ambient temperature. If the cable is rated to carry 40 amps nominally, the allowed current would be allowed current equals 40, 0.82 equals 32.8 amps. Everyone gets warmer, right? The same applies to cables. Bundling cables together increases heat, which affects their current carrying capacity. When possible, space out your cables or use perforated trays to let them breathe. Your cables will thank you. Standards such as IEC 60364-5 provide grouping correction tables based on the number of cables and their arrangement. Practical example, consider a group of 4 4mm squared cables bundled together. If the nominal current rating is 30 amps, the correction factor is 0.84. The allowed current is calculated as allowed current equals 30 times 0.84 equals 25.2 amps 3. Voltage drop is like losing water pressure in a long garden hose. The farther you go, the less water or voltage reaches the end. To ensure reliable system performance, the chosen cable must limit the total voltage drop across the system to no more than 5% of the rated system voltage. Excessive voltage drop can lead to poor performance or even malfunction of connected devices. According to IEC 60364 standards, the total voltage drop should be kept under 5%. Voltage drop calculations can be performed using predefined tables or formulas. Calculations are based on cable length, current, and resistance using standard formulas or reference tables. Practical example, consider a 10 mm squared cable carrying 50 amps over a distance of 50 meters. This value is within the acceptable limit of 5%. 4. Short circuit current capacity. Your cables must endure short circuit conditions without getting fried. It's like making sure a bungee cord can handle your weight before jumping off a bridge. Reminder, always verify the short circuit rating of your cables against system requirements. A cable that survives short circuits is a cable that lives to fight another day. Scientific impact. During a short circuit, extremely high currents flow through the system for a short duration, potentially causing excessive heating in the cables. According to IEC 60364 and IEC 60909, the cable must be selected to withstand the short circuit current while maintaining its insulation integrity. Practical example, let's consider a motor control center in an industrial facility. If the short circuit current for a fault is 15,000 amperes and the fault duration is 0.5 seconds, using a copper cable with XLPE insulation, K equals 226. Required cross-sectional area, A equals approximately 497.8 square millimeters. The nearest higher standard size would be 500 square millimeters. 5. Installation method. Where and how you install your cables, underground, overhead, or in trays, impacts their performance. Scientific impact. The method of cable installation plays a significant role in determining its current carrying capacity. Different installation methods such as air installation, installation in cable trays, inside pipes, or underground, each have specific correction factors that are determined based on the IEC 6364 or national standards. Practical example, according to the tables in IEC 60364, the permissible current for a 4 mm squared cable at 30 degrees Celsius with installation method C on the wall is 28 amperes. If the installation method changes to B1, cable inside a pipe within a wall, the permissible current is multiplied by the correction factor of 0.8. Corrected current equals 28 times 0.8 equals 22.4. By understanding and applying these factors, you're not just selecting a cable but ensuring the safety, efficiency, and longevity of your electrical systems. Ready to size your next cable correctly? Let's put theory into action. Practical example, calculating cable size. Given data, let's say you have a motor rated at 150 kilowatts operating at 400 volts with a power factor of 0.8. Step 1, calculate full load current. Using the formula seen will give us the values, approximately 271 amps. Step 2, size multiply by the NEC safety factor 1.25. Using the formula seen will give us the values. Apply correction factors. Ambient temperature. At 45 degrees Celsius, use a correction factor of 0.82. Grouping. For 2 circuits, apply a factor of 0.88. Using the formula seen will give us the values. From standard tables, a 120 square millimeter copper cable fits the bill. Tip: double check with local standards as cable sizes may vary regionally. Step 4, calculate voltage drop. For a 120 square millimeter cable, resistance is 0.153 ohms per kilometer. For a length of 30 meters, voltage drop approximately 2.49 volts. Percentage of system voltage of 400 volts is around approximately 0.62%. This is far below the 5% limit. Short circuit capacity. Check the 120 millimeters squared cable's fault tolerance. If it passes, congratulations, you're ready to go. Conclusion: getting cable sizing right ensures safety and efficiency. Just remember, consider temperature, grouping, voltage drop, and short circuit capacity. Oh, and don't forget to check your local codes and regulations, and maybe keep a multimeter handy for the adventurous electrician. Final note: for more insights, practical tips, and maybe subscribe to our channel. See you in the next video.